if part B is slightly more difficult, find the time taken by P to hit the pulley from the instant when P is released. So to start with, P is initially at rest, and then it travels for a distance of 0.4 metres. At the point when it's travelled 0.4 metres, this is the point when Q hits the floor. So up to then, there's an acceleration of 4.2 metres per second squared acting on P. Once Q hits the floor, this tension in the string now becomes zero because the string has become slack. So what we need to do first of all is work out the time it takes for P to travel that 0.4 metres. So we know for P, the initial speed is 0. We know it's travelling at an acceleration of 4.2 metres per second squared because it's going to accelerate at the same rate as Q was. We also know that the distance it travels is 0.4 metres. So we've got 3 bits of information there, so we can use one of our Suvat equations to find how long it takes to travel that 0.4 metres. So if we use our v squared equals u squared plus 2as equation, so v squared equals, and then obviously u squared will be 0 squared, so it's just 2 times the acceleration times the displacement. So if you work that out and then square root, v comes out as 2 root 21 over 5 metres per second squared. So we know at the point when Q hits the floor, P is travelling at that speed. So we're now looking at P travelling the rest of the distance until it reaches the pulley. Well, that distance is going to be the remaining, it was 1.5 metres from the pulley, it's just travelled 0.4, so we know it needs to travel another 1.1 metres until it hits the pulley. So we know the speed it's travelling in is going to be 2 root 21 over 5. So that's the initial speed. We don't know what speed it hits the pulley at. We're not really interested in that either. We know it's got to travel 1.1 metres. We're trying to find how long it takes to travel that 1.1 metres. We obviously need some other bit of information in there. So if we resolve on P in the direction that P is moving in, okay, once a string goes slack, there are no forces acting on our particle because that string has gone slack. So if we use our F equals ma equation, there are no forces acting now because it's a smooth surface, there's not even a resistance to the particle, equals the mass of the particle times a. So that means the acceleration is 0. So effectively it's travelling at a constant speed. So using then one of our equations, so we could use our S equals ut plus half at squared. If we substitute, that was to find the time here, because we also need to find how long it took to travel the 0.4 metres. So I'm going to continue with this information for the moment. So using this, we can work out the time it took to travel that 0.4 metres. So 0.4 equals the initial speed, which was 0, times time, so that will be a 0, equals a half times the acceleration times t squared. So from there you can work out the time taken to travel that initial 0.4 of a metre. That should be 2 root 21 over 21 seconds. So at the moment that's our time taken for that initial bit. If we continue with this one here now, so trying to find this time for the remaining bit of the journey. So again, if we use an equation there, so again use our S equals ut plus half at squared. So we're travelling a distance of 1.1. The initial speed is 2 root 21 over 5 times t, and then plus half at squared. Well, if a is 0, that term is going to be 0. So if we divide 1.1 by 2 root 21 over 5, that should give us t as 11 root 21 over 84. So we've got 2 times. This is the time it took to travel the initial 0.4 of a metre. This is the time it took to travel the rest of the distance. So if we add those two answers together, we get the total time. So I'll do that up here. If you add the two times together, 1 plus 2 is 1.04 seconds altogether.